Hello and welcome back to the channel. In this video series, we're continuing to review the principles and practices of commercial construction textbook. So this video is about chapter 9, and that is masonry construction. So you already know that because of its low tensile strength, the use of unreinforced masonry has been limited primarily to building components loaded in compressions, wall, columns, and arches. In wall construction, two types are defined. The first type is where masonry walls support the floor and roof framing and all other superimposed gravity loads. This approach is known as load-bearing wall construction. And the second type, where a separate structural frame, such as structural steel or reinforced concrete, supports the gravity load and the masonry wall fills in the spaces between columns and beams, and that is known as non-load-bearing construction. So, non-load-bearing wall construction can further be separated into two subcategories, and those are partition walls, and that's the wall in the interior, and that supports no load. If the wall is on the exterior of the building, it's known as a curtain wall. Although curtain walls do not support gravity loads, they must be designed to resist lateral loads due to wind and be able to transfer those loads to the supporting structural frame. So let's move to the next subsection, and that is building with concrete block units. So concrete block units are manufactured using a dry, no-slump concrete mix of Portland cement, fine aggregate, sand, and water that is fed into a mold using pressure and vibration. To to lighten the units, lightweight aggregates are used instead of normal density fine aggregates. And once the units are removed from the mold, they are steam cured at the temperature between 122 to 176 degrees Fahrenheit for about 16 hours. So concrete block units were developed as an alternative to brick, clay tile, and cast-in-place concrete in the construction of load-bearing walls, such as basement walls. Being larger than bricks, they can be placed at a much faster rate and provide a good bearing surface to support floor and roof framing. So typical dimensions of a standard block are here. So that is the length is 15 and 5/8 inch. The height is 7 and 5/8 inch, and the thickness is the thickness of the walls is 1 inch. And also, let's take a look at the half units. So both in width and height, they are available to provide more flexibility for framing openings for doorways and windows. So to produce a wall 8 feet high, it takes exactly 12 units. So also, and there is an example here as well. Let's take a look at that. So a standard 8-inch block unit has face dimensions of 15 5/8 and length 7 and 5/8. So adding 3/8 of an inch for a mortar joint produces a unit measuring 16 inches by 8 inches. And yeah, so to produce a wall of 8 feet high, it takes exactly 12 CMUs. Masonry brick sizes are designated by their nominal width. Nominal widths of units range from 4-inch to 12-inch in 12-inch increments. Standard blocks have an actual height of 7 and 5/8 inch and an actual length of 15 and 5/8, allowing for 3/8 inch mortar joint. I reiterate that because that is important. So the actual widths are 3/8 inch smaller, allowing for the interlocking of units at building corners and wall intersections. So please refer to the images here. You can see that there are different variations of the CMU, such as you can see the standard one, you can see the corner sash, you can see the bullnose corner, you can see half block, you can see a lintel and a pilaster. Also, there are different patterns um, and also different ways of stacking them. So you can see the single width, you can see solid multi-width, and you can see the cavity. And we'll take a look at all of them in a second. So blocks are laid in two basic patterns of bonds, running bond or stack bond. Running bond consists of placing the units so that the units are staggered so that the units overlap 50% for each successive row. In the stack bond method, the units are stacked so that the vertical joints from a straight line. The type of bond used in many cases is based on architectural requirements and local building practices. Again, refer back to the textbook. Always back up the videos with the images, just because this is how important it is to see that, because there are graphics, there are sections, there are actual photographs of the process. So this is critically important to understand. Concrete block bearing walls must be provided with horizontal or vertical supports at right angles to the face of the wall. Vertical support may be provided by cross walls, pilasters, or buttresses. Horizontal support is provided by floors or the roof. Structural codes provide guidelines for maximum distances between vertical and horizontal supports to ensure that walls do not become too slender. For example, load-bearing walls or hollow or solid block units are allowed a maximum height to thickness ratio of 20:1 with a minimum nominal thickness of 8 inches. Non-load bearing walls have the same limit. However, the minimum thickness can be reduced to 6 inches. Cavity walls must be composed of units with a minimum nominal thickness of 4 inches in each width, and the width thickness ratio is calculated on an equivalence thickness that is 2/3 of the sum of the individual widths making up the wall. So to provide maximum stability and to increase the strength of block walls, the following practices are recommended. 1. Choose blocks of good dimensional stability. 2. Keep blocks dry at all times, particularly during site storage and laying operations. 3. Use horizontal joint reinforcement, especially around wall openings. 4. Provide control joints at appropriate locations. And 5. Use bond beams where feasible. So continuous horizontal joint reinforcement is provided by embedding specially fabricated wire reinforcements. Please again refer back to the images to see that. During construction, concrete block units with no lateral support are extremely susceptible to the effects of wind. It is imperative that some temporary bracing be provided to walls during construction until permanent lateral support is provided by other building components such as floors and roofs. Temporary bracing must be sufficiently rigid and stable to resist the local design wind loads for the building location and should be checked by qualified design personnel. We're moving to the next subsection, and that is reinforced masonry. So the Concept of reinforced masonry was developed to improve the versatility of masonry units in building construction. Traditional masonry structures were based solely on the compressive properties of the masonry, and rules of thumb were derived in some instances by trial and error for wall thicknesses and distances between lateral supports. Reinforcement of masonry is based on guidelines similar to those in reinforced concrete. As in reinforced concrete, the reinforcing bars provide the tensile strength that sections of plain masonry lack. The rebars are placed in voids of the masonry sections and are bonded to the masonry with grout. The outcome is that columns, beams, and walls can be sized and evaluated using standard engineering formula. The next subsection is mortar and grout. So mortar is a mixture of sand, lime, cement, and water and serves as a bedding material for the masonry units. It allows the mason to make adjustments for irregularities in the masonry units as well as variations in the supporting structural framework on which the units are being placed. So two properties of mortar are paramount, and those are its strength and its workability. The mason is primarily interested in workability, whereas the designer is concerned with strength, and some balance must be obtained to satisfy both. The amount of lime used determine the workability of the mortar, whereas the amount of cement used will determine the mortar's final strength. If the cement content in the mix is increased, the strength increases. However, a corresponding loss in workability results. Mortar must not only have good workability and strength, but it must also be compatible with the masonry units that it bonds. Different masonry units have different expansion and contraction coefficients, and when used in various combinations, the mortar must be able to resist the resultant stresses that are produced. In this case, a weaker, more flexible mortar will perform better than a strong and more brittle mortar. Careful thought to the location of control joints in this instance will help minimize undue stresses in the mortar. Until recently, 5 mortar types were recognized by Masonry Code. It's MSNONK, and you can memorize it as a masonry work. So the M is the strongest, but was found to be too brittle and lacked workability. Types O and K, on the other hand, were found to be too weak for the slender walls that are now being used in building envelopes. The latest masonry codes dealing with mortar specifications lean toward the use of the two mortar types, S and N. These mortars have sufficient strength for the stresses that are imposed on them and yet exhibit the necessary properties such as durability, water retention, bond strength, and workability that are important to the mason and the designer. So mortar may be mixed on site in a portable mixer or may be obtained in a pre-mixed fashion from a mortar supplier. Mortar mixed on the job site can vary in consistency because of variations in the moisture content of the sand and the accuracy of the proportions that are used in mixing. So if mortar strength is a concern, random test samples may be taken and tested for strength periodically. Care must be exercised in preparing, transporting, and testing mortar specimens, as small disturbances can greatly affect their test results. Premixed mortar must be ordered in appropriate quantities so that it can be used before it begins to set up in the container and loses its workability. So again, please refer to the images. You can see different pre-mixed mortar and mortar mixers here. You can see the rebars in the masonry wall, and you can see the horizontal reinforcing wire in the mortar joints. So that is important to see as well. Um, so grout, let's take a look at that. Grout may be placed in two ways: low lift grouting and high lift grouting. So low lift grouting begins when the wall or column has reached a height of approximately 4 feet. With the reinforcing bars in place, grout is added to the masonry to no more than 4 feet, and the mason then continues to add courses of masonry for the next lift. What is important to ensure here is that the rebars extend sufficiently beyond the top of the grout to allow for a lap of at least 30 bar diameters with the bars in the next lift. So high lift grouting is usually done when the wall or column sections has been raised a full story. The advantages of high lift grouting is that the steel reinforcing can be placed after the wall has been completed, and larger amounts of grout can be placed at one time without interrupting the mason. However, the wall must be provided with openings at the bottom of the wall to allow for the removal of mortar droppings. And we are moving to control joints. So control joints are vertical joints that separate walls into sections and allow freedom of movement. They should occur at intervals in long, straight walls where abrupt changes in wall thicknesses take place. Also at openings, intersections of main walls and cross walls, and at locations of structural columns or pilasters in main walls. So to produce a control joint, uh, place building paper on a coat of asphalt paint on the ends of the block on one side of the joint. Fill the core with concrete or mortar to provide lateral stability. Single wire ties may also be used across the joint. Rake the mortar in the control joint into a depth of 3/4 inch and caulk with a suitable compound. Caulking may be omitted on the interior face and the joint finished with a deep groove. So again, please refer to the images here in the textbook. The next one is bond beams and lintels. So the primary purpose of bond beams is to act as a continuous tie for exterior block walls where control joints are not required. So a bond beam is a continuous cast in place reinforced concrete beam running around the perimeter of a building or between control joints. It's formed by using standard lintel blocks, deeper bond beam blocks, standard blocks with a large portion of the walls cut out, or forms of wood or steel. So lintels, lintels over openings in block walls may consist of precast concrete units or may be cast in place. So again, please take a look at the sections. You can see the rebars, you can see lintel blocks, and you can see the joint reinforcement, how that works, as well as the lintel reinforcement. And you can see the shoring, you can see lintel, you can see half jam block and full jam block. So that is critical important to understand how that works. So also, um, there are some screen blocks, and there's a large number of shapes available that creates a great variety of patterns possible for a block wall. It's usually good to consult with a sales rep because they know their product, they know how they combine with each other, and they know what to recommend. So screen blocks are available to add to the variety or to build open walls that are to act as solar screens. So there are different types of blocks such as the V, double V, and double X blocks. And I'm sure you have seen those many times in the residential construction. So customized concrete block masonry. Um, that what that is, there are a few block faces that are available, and you can find them in both standard and metric sizes. And it's just for the design purposes. There are so many different variations, and a block producer should be consulted to determine what designs and local plant is capable of producing before actually specifying those. Again, please refer to the images. You can see uh, the the blocks here. You can see the customized concrete block units with a rounded groove, with a tri-face, deep groove, hex face, split rib, random scored, split sawtooth, and fluted. So I'm sure you've seen some of those in the construction. So, and we are moving to the next subsection, and that is prefabricated concrete block wall panels. So the recent innovations include the utilization of new mortar systems and the development of prefab concrete block wall panels. So as far as the mortar systems, we have a strong adhesive now known as organic mortar. It is applied to masonry joints with a gun and replaces the usual Portland cement mortar. And a variation of this system is in use with an organic additive to Portland cement to increase its flexural strength from 2.5 times. And this mortar system is commonly used with autoclaved aerated concrete masonry. Another system is known as surface bonding, and that uses a mortar composed basically of Portland cement reinforced by the addition of glass fibers to increase the tensile strength. Panel fabrication. Wall panels are fabricated by two different methods. In one, block layers or masons portion of the unit in the wall panels, whereas the other involves the use of a block laying machine. The manual system can be employed either in a plant or at the job site uh, in all weather enclosures on what are called launch pads, but the machine operates in a prefabricated plant or factory. A block laying machine lays blocks in either running or stack bond, inserts the joint reinforcements, makes the bed and head joints, and tools them. Under the manual method, blocks may be laid with conventional mortar, organic mortar, or no mortar. In that case, surface bonding is employed. And we are moving to the tie-in systems. So with conventional CMU, the tie-in systems between walls and floors or walls and columns have been relatively simple. The development of block panel construction has meant the need for strong connections between adjoining walls and between walls and floors. So horizontal edges, like wall to floor edges, may be connected by spliced reinforcement, tension connections, bolted tension connections, bolting, or welding. And the vertical edges, such as wall-to-wall edges, may be connected by steel plates, lapped reinforcement, or formed lap reinforcement. I highly recommend to take a look at the images here. So, wall-to-floor ties. The spliced reinforcement system is much the same as that was used in the joint precast concrete panels. So the bottom ends of reinforcing bars have a coupling nut attached, and then the walls, when the walls are in place, that is like the bar is threaded on one end is attached to the upper bar by the coupling nut, and to the bottom one by welding. So also, yeah, there is another section. You can see the spliced reinforcement connection. And the tension connection provides a way of tying the panels together through a block course from top to bottom of the building. Panels are brought to the job site with loose vertical bars in their cores. Each bar has a threaded eyeball attached at the top and a steel lifting plate and nut at the bottom to act as a lifting device. Again, please refer back to the images and you will see a few different, you will see the tension connection and you will see the bolted tension connection here. So when we move to the wall-to-wall types, there are several types of connections that are used, and they include the steel bar connection, a lapped reinforcement connection, and a lapped reinforcement with formed joint connection. In the steel bar connection, a flat steel bar with its ends bent in right angles is preset in the top edge of the panel. A cutout in the top end block of the adjoining panel makes installation easier. After the second panel is in place, and the end core is grouted to anchor the bar. And please refer to the images. You can see the grout on job. You can see a flat rebar connection, as well as the lapped reinforcement and lapped reinforcement with formed joint. So lapped reinforcement consists of harpin-shaped bars placed in alternate block courses with their loops projecting 2 inches past the vertical edge of the panel. And lapped reinforcement with form joint is similar to the previous one, but the regular end blocks are used and the panels are spaced 2 to 3 inches apart when in position. So let's move to the next one, and that is the brick construction. So fired clay bricks have been used as basic building units in the construction of buildings and various other structures for centuries. So basically, people say it's like 100 years, no maintenance. And the strength and durability of brick made it an ideal material for the construction of load-bearing walls and as an exterior finish. In spite of the many materials that are available today, building designers continue to incorporate brick into new structures because of these properties. To satisfy the requirements of modern building designs, the manufacturers now provide a good selection of brick sizes with varied colors and textures. So refer back to the images, take a look at how the arches are constructed. So let's go back to the brickwork fundamentals. Building with brick may involve the construction of solid brick walls, walls of reinforced brick, brick cavity walls, or brick veneer walls. The terminology used in connection with various positions of brick in a wall applies in all cases, and almost any of the numerous pattern bonds available may be used with one of these walls. The structural bond involved will depend on the type of wall. The third type of bond involved in brickwork, the mortar bond, is a function of the type of mortar used. So please take a look at the typical brick walls. You can see solid brick walls as well as the insulated cavity wall and also brick veneer bonded with reinforced grout core. And here there's another one that is the reinforced brick wall. So let's take a look at some common terms used in brickwork. Again, images are beautiful. Please take a look at them. So you can see the variations here. You can see two common brick patterns bonds, and those are Flemish bond. You can see the English corner and Dutch corner, and you can see English bond. So also please take a look at how the course is going. You can see the face brick, you can see the width, you can see a stretcher, you can see roll block, roll lock, and then roll lock header, and header soldier. Um, and you can see also mortar joints. Also, there is another type of brick, which is the SCR brick with the hollow openings in the middle. So let's take a look at all of them here. So sand mortars used in brickwork use the same components as mortars in concrete block construction, a combination of sand, cement, and lime. Cements that are normally used are ordinary Portland cement or masonry cement. And the use of masonry cement has the advantage that additional lime does not have to be added to the mix. So when normal Portland cement is used, the cement content determines the compressive strength of the mortar, and the amount of lime determine the workability of the mortar. Masonry standards such as ASTM C270 and CSI A179 provide guidelines for the proportion of mortar components to ensure that the required strength and workability of the mortar mix is achieved. So there are two means of specifying mortar. One is to specify the minimum compressive strength, and that is known as the property specification. And the other method is the proportion specification, such as a prescriptive method that assumes reasonable properties will be met, provided the proportions are followed and mixed properly. So one or the other should be used, but not both. So again, please take a look at the mortar types for brick, and that is S, N, O, and K. So types O or K may not be used where masonry is to be in direct contact with the soil, where an isolated pier is to be built, or where the wall is exposed to the elements on all sides, as in the case of a parapet wall. So please take a look at the images, and there is a chart as well. You can see the parts by volume and the compressive strength here. So we are moving to the reinforced bond beams, and you can see the sections here. You can see that the brick walls may be further strengthened by the use of bond beams. And for example, in case of a three-width wall, the two outside widths act as the form. Side forms must be provided for a bond beam in a two-width wall. Vertical reinforcement should extend through the beam. Please again refer to the images. Um, um, Also, let's take a look at the vapor barrier. In the form of an asphalt coating is usually applied to the cavity face of the inner width. Weep holes must be provided at the bottom of the outer width to allow the cavity to drain. During construction, um, the mason should ensure that the weep holes are properly installed and that they are not blocked by falling mortar. Plastic inserts, oiled rods, sash cord, or flexible plastic foam strips can be used to form the drain holes. The plastic inserts are preformed and are left in place. Brick veneer construction consists of applying a 4-inch width of brick as facing material over a backup wall. The backup wall may be of frame construction or a masonry wall of common brick, structural clay, tile, concrete block, cellular blocks, or cast-in-place concrete. In any case, the load-bearing properties of brick are not utilized. Structural stability of the facing width is obtained by anchoring the veneer to the backup with metal ties or by grouting it to the wall with a reinforced grout core. And usually it's 1 inch thick. Lintels. The support of the masonry over openings in brick walls is an important consideration. This support will be provided most probably by a lintel, which may be a reinforced concrete unit, a reinforced brick structure, or a built-up structural steel member. Please again refer to the images here. You can see the brick lintels. You can see how it's reinforced. You can see two angle lintel. You can see wide flange and angles lintel, as well as the channels and angles lintel and I-beam and plate lintel. So reinforced brick lintels are similar to bond beam. A support must be made on which to build a lintel, and the brick is laid in running bond with full bed and head joints. Horizontally reinforcing steel may be laid in the mortar joints as the units are laid, or the lintel may be built separately. Flashing. This is critically important. Um, so the purpose of flashing is to exclude moisture or to direct any moisture that may penetrate the wall back to the exterior. To perform satisfactorily, flashing must be a permanent material and must be properly installed. Most flashing is made of sheet metal such as copper, lead, aluminum, or galvanized iron, fabric saturated with asphalt, or pliable synthetic material. Copper and bituminous material are sometimes combined to form flashing material. So two types of flashing are in common use, and those are external and internal. External flashing prevents the penetration of water at points where walls intersect flat surfaces such as roofs. Internal flashing is built into and usually concealed in the wall to control the spread of moisture and to direct it to the outside. Sometimes it's called through wall flashing. So the points at which flashing should be installed are as follows. There are 9 of them. So it's the first one, above grade in exterior walls. The second, under and behind window sills. The third, over lintels. The fourth, over spandrel beams. The fifth, add projections or recesses from the face of a wall. Six is under parapet copings. Seven, at intersections of wall and roof. And eight, add projections from the roof, such as ventilators and penthouses. And the last one, the ninth, is around chimneys and dormers. Again, please refer to the images. You can see flashings in brick construction. You can see solid wall, cavity wall. You can see recess, projection. You can see the belt and also other aspects. And we're moving to the expansion joints. They're needed in brick construction under certain conditions. So the purpose is to provide separations in a structure so as to relieve the stresses set up by changes in temperature in moisture conditions or caused by settlement. They should generally be located at offsets. If the wall running into the offset is 50 feet or more in length, and at junctions in walls. So the molded copper wall stop used in the vertical joint on the outer face. Sealant is later applied to seal the joint. A pre-molded expansion joint material is used to separate the sections of backup wall, and the vertical joint on the face is covered with a metal plate, which is fastened to one section only. Again, please take a look at the images, expansion joint in brick construction. You can see how that is done. You can see the positions of expansion joints as well as the wall intersection, how that is created. You can also see the backup tile, and you can see the pre-molded filler and metal expansion joint cover tap screw on one side. So load-bearing brick walls. Um, so until recent years, the design of brick buildings was based on the empirical requirements of building codes with regard to the minimum allowable wall thickness and maximum height. So those regulations often placed economic restrictions on load-bearing brick walls for buildings over 4 or 5 stories in height. New developments um, that are happening now, in which the design of load-bearing wall is based on a realistic structural analysis of the proposed building. So as a result, relatively thin load-bearing brick walls are being extended to as much as 18 stories. Design include the interior and exterior walls for load-bearing purposes, and the thickness of all walls can be reduced. Please refer to the images here. You can see how that is done. So some examples of the structural details of the thin load-bearing walls and the variety of floor systems possible with them are actually here in the textbook. You can see them here. Please, you don't have to memorize that, but just it's for your general information. So when we talk about prefabricated brick panels, what is important to remember here that the same techniques used in the prefab of concrete block wall panels are applied to the production of prefab brick panels. Some are veneer type, just one brick thick, and some others are load-bearing walls with combined brick and block bonded by grout filler collar joints and wire reinforcements. The development of high bond mortar is the key factor in the increasing use of prefabricated brick panels because a new mortar will produce 400 to 300 to 400 psi of flexural strength compared with approximately 150 psi for conventional motors. So after about 7 days curing, panels are ready for installation. They are filled into place by a crane and anchored, usually by welding pre-located weld plates into the structural frame. And again, you can see these images here. So we are moving to second to last subsection, and that's building with stone. We will have cold weather masonry work left, and we'll be done with this section. So building with stone, um, stone has been a major structural material in the past, but modern builders use it almost always as a veneer or curtain wall material. So as a veneer, stone is laid up to a masonry backup with a few patterns. It's ashlar or rubble. So ashlar patterns feature cut stone laid with well-defined coarse lines, whereas rubble patterns use uncut or semi-cut stone laid with few to no coarse lines. So stone for ashlar work are produced in thicknesses 2 to 8 inches, and the height is 1 to 48 inches, and the length is 1 to 8 inches. Methods of bonding stone veneer to backup walls vary, and that depends on the size of the stones, and that depends on the popularity of the style as well as the jurisdictions. For small stones, ties similar to those used for brick and tile facing work are commonly used. For larger stones, and particularly when the backup wall is non-bearing, a variety of anchor types are available. And you can see there are different stone anchors here shown. There are a lot of them. You don't have to memorize them, but you need to know which one to use where. So two methods are used to support stone veneer or non-bearing walls. One method involves the use of shell angles at the spandrel beams as shown here in the textbook again. And the stone is held in place on the shelf by half-inch rod welded to the horizontal leg of the angle or by dowels protruding through the horizontal leg. So again, there are images supporting that. Please refer back to them and you will see how that is constructed. So the second method, bond stones rest on the spandrel beam and provide support for the rest of the veneer. Anchors are not required in the bond stones themselves, but are used between bond stones and regular veneer slabs, and between veneer and the backup wall. Again, see the images, they are very informative. Belts and copings are secured by strap anchors or dowels, and sills, lintels, and quoins are built into and supported by the masonry surrounding them. Some ashlar is anchored in solid backup walls with non-corroding corrugated wall ties and with bond stones where the backup material will allow it. If stone course lines do not coincide with those of the backup material, toggle bolts are used to secure the wall ties to the block or tile. And again, please refer to the images of this textbook. So wire brushes and acids should not be used to clean stones. As soon as possible after the mortar has set, They should be cleaned with water, soap powder, and fiber brushes. Approved machine cleaning process may also be used. So we are moving to the last subsection, and that's cold weather masonry work. So we know that the precautions must be taken when placing concrete in cold weather, and that the same precautions apply to the masonry work as well. So unless protection is provided, the mortar bond may be very poor, resulting in inadequate strength and high permeability. Adequate protection should be provided for at least 48 hours. So warm mortar is the first requirement. Sand may be kept warm by piling it around a large pipe heated by a gas jet, and it should be turned over periodically to maintain at even distribution of heat throughout the pile. Warm water should be also used, but the temperature of the water will depend on the sand temperature. So, and you can see the images here. So, masonry units should also be warm to prevent the sudden cooling of warm water as it comes in contact with cold masonry. It is often difficult to store quantities of bricks or blocks in heated enclosures. And the alternative is to heat a smaller quantity of units just before they are to be used. So again, please refer back to the images. You can see how the blocks are heated prior to use. And you can also see laying block behind the protecting tarp. So that was it for section 9, for chapter 9. Thank you so much for watching. I will see you in chapter 10.